Good morning, everyone. Today I'm gonna talk about lenses, right? So let me quickly go over what we did last time about the mirror, right? Last time, I introduced two different type of a mirror, right? So first one is a concave and converging mirror, right? Concave because of its shape, right? And then converging because of the direction of the light, right? So for example, this is called concave mirror, and then it's also called converging mirror because all light after reflection will be converging to the focal point. And then another type of lens is a convex or diverging mirror. Again, because of convex because of its shape, and then diverging because of the direction of the light. After light reflected, it diverges to all direction, right? Spreading out everywhere, right? And then there's two important points for the mirrors, right? The one is the center of the circle, and then this is second one is the focal point, which is halfway, right? And we also, draw the ray diagram, right? The first line is always a parallel to this main line, right? So which is the first line, and then reflected to the focal point. So parallel focal is your first line, and the second line is directly to the center of the circle, and then this is where your images are formed. And then we had a few different type of object, and then we also find the image property of a mirror, right? So image can be real or virtual. How you distinguish this? Real, especially when the image is formed same size as the mirror, right? Virtual, if your image is formed behind the mirror. And then we can also find the image property upright based on their direction, right? Upright or inverted or larger and smaller, right? That's what we did last time. And today we had some examples drawing, right? And today we're gonna talk about lenses, right? And the lens also has a two different type of lens. Because of their shape, we have a concave or convex. But think about the name of the mirrors, right? Convex mirror or diverging mirror. But now, if it's a lens, converging lens and the convex lens are the same name. And then diverging lens or concave lens. This is because of their shape, and this is again because of the direction of the light after refraction, right? So the main idea here, main differences, sorry, between mirror and lens is here. Mirror, we only use one side, right? The other side of the, let's assume this is a mirror, and then let's assume we are using this side of the mirror, meaning that your face is gonna be here, right? So the other side is basically, wood or another, materials that we don't use. But lens, are transparent. And then in general, we're gonna work on these two type of lens only, which is symmetrical. And then again, these lenses are transparent. So then basically we can in place your object both sides because this is symmetrical and then transparent, right? So in other words, that means mirror, you have only one focal point. A lens, you have a two focal point with both type, both side. So basically you can use any of them. Again, in addition to that, let me see your name again because it's called convex lens because of its shape, and it's also called converging because of the light. See, when the light passes through reflected, and then it will converge to a focal point. And then because of this shape, it's called concave. But when the light is reflected, it will diverge. So that is called diverging lens, right? And then you have a pretty same property like the mirror. As I said earlier, lens has a two focal point. So that means your object can be either side. And then same for the converging lens, diverging lens, they both have a two focal point, right? And then of course this is a symmetrical. And then the focal point must be on the principal axis as well. Okay. And then rays parallel to the main axis converge at the focal point on the opposite side of the lens for the converging lens, right? So that means if you have a lens, if your image is formed opposite side of lens, then that is called rear imaging, which is different from mirrors. Right? And then ferro lays parallel to the principal axis appear to diverge from the focal point on the incident side of the lens. That's a diverging lens. Right? We'll talk about more details with the actual pictures. Right? And then we need to draw ray diagram for lenses. So image formed by refraction. This time you see, make sure lens you have a refraction, while mirror have a deflection, right? So refraction of the light through a lens can be constructed by the graphic procedure similar to the spherical mirrors. And then we are again interested in location, orientation, and the size of the image, right? And then in order to construct the ray diagram for lens, we again need two lines. The first ray is drawn parallel to the principal axis, which is the same as a mirror, right? It's the first line parallel to the principal axis, then reflected by the lens through the focal point. Same, parallel, focal. The second line is drawn through the center of the lens. So what was the second line for the mirror? There was the second line is the center of the curve, right? Circle, right? So that's the only differences. Right? So then now let's draw it. For example, your object is here. For example, your focal length is a 10 centimeter. So then you again have the same focal point at the other side as well. And then let's assume your object is placed here about 20 or 18 centimeter. Again, first line parallel reflected to the focal point. And the second line directly toward the center of the lens. And then this is where your images are formed, right? So then now you see, make sure, assuming you have a red area and for example, blue area bottom, right? And then this is the place where your blue part, and then this is the place where your red part will be formed, right? Don't assume your red is here, blue's gotta be bottom. No, okay? So for example, why? If you follow this point, for example, first line parallel, right? And then to the focal point. And the second line directly to the center. So you see, this is where this portion, this part of the, green one will be formed. And the red one, again, you will see will formed here, right? So make sure, the image is formed in a completely, up, like a mirror. You assume you have a mirror in the red side here, blue side here, right? So the image property, you see the size is not clear. It seems like it's slightly bigger. And then direction is inverted. And then rear image again. Why? Because your image is formed opposite side of the lens, right? And the second case, you're now the difference is that your object is further from the focal point, but now your object is somewhere between focal point and the lens. Again, but the rules are the same. First line, parallel to the focal point. Second line, directly to the center. Then you'll see these two lines spreading out. They're never gonna meet. Then you expand your lines to the other direction, right? And then this is the location where your image will be formed, right? So then now image size is a bigger, direction upright, and then now this is your virtual image, not real image, because your image is formed same size as the object, right? So then now let's assume you're drawing image ray diagram for diverging lens. Again, your diverging lens has a two focal point, but your diverging lens, you gotta use the focal point the same size as the object. You see the differences. This is your converging lens. Again, you have a two focal point, but we didn't use this focal point, but we used this focal point, which is a opposite side of the object for the converging lens. But if it's a diverging lens, we gotta use the focal point, which is the same size as the object. So then rules are the same. So basically, we're not interested in this focal point. First line, parallel, and then toward the focal point. And the second line, directly to the center of the lens. So now your image will be formed here. Obviously smaller, and this is a upright. And again, this is a virtual because your image is formed the same size as the object, right? Again, for the mirror, if your image is formed the same size as the mirror object, then that's a rear. But the lens, if your image is formed the same size as the object, that is a virtual. So then now we have a convex lens, right? So which one is a convex lens? So be careful about their name, right? Sorry. Okay, so this is a convex lens, right? Converging lens. So now we have a convex lens. Focal length is a 12 centimeter, right? And then draw the ray diagram for the object 8 centimeter from the lens. Again, you can scale when you draw your ray diagram, right? So basically, this is a 12 and 18. So you can basically say, 6 centimeter is 1 unit. So then now you draw the convex lens, and then you draw the central line, right? And then focal point is basically 12 centimeters. So now, okay, this is roughly my 1 unit. And then, so this is my second unit. And then you see 1, 2. So this is my first focal point. And then this is gonna be my second focal point. And then this is a 12 centimeter. And this is a 12 centimeter as well, right? And then your object is placed at 18 centimeters. So you have another 6. So this is gonna be your object location, right? And then now we are drawing ray diagram. First line, parallel. And then because this is a convex lens, we gotta use this focal point. We're not gonna use this focal point. But if you place your object here, for example, you will use this focal point instead of this, right? And anyway, so the first line parallel reflected to the focal point. And the second line directly to the center of the circle. Then you see your image will be formed somewhere here. So my drawing is horrible. So let's see this drawing, right? Parallel, first line, parallel, focal, second line directly to the center, and this is where your image is formed. So then now you see this image is inverted, of course, and the magnified, in other words, is larger. And then again, this is a real image. Why? Image is formed opposite side of your object, right? This is your object. And then another example, you again have a convex lens, right? Focal point to 12. And then now you have you're drawing object 8 centimeter from the lens. So then we do the same thing. Okay, this is my lens. And then this is my principal axis. And then this is the center. So this is 1 unit, 2 units, so which is your focal. And then you again have a 1 unit and 2 unit, which can be another focal point. But now let's assume your object is 8 centimeter. So sorry, I think this is 12 centimeter and then 8 centimeter. You better to assume 4 centimeter is 1 unit. So let me redraw it. So instead of saying this, I'll say I'll have a one more unit, which each of them is a 4 centimeter. So then your focal point, and then this is focal point. So obviously this is 12 centimeter, and the other one is a 12 centimeter as well. So now your object is a 8 centimeter. So then this is where your object will be, right? And then again, first line parallel reflected to the focal point. The second line directly to the center. Then you will see these two lines never gonna meet, and then you expand your line here, and then this is gonna be your image, right? So then let's draw, but this is the other side. But now you see first line parallel, focal, second line directly to the center. But again, we don't use this focal point, but we'll use this focal point. Okay? And then, yeah, we don't have any more example here, but I'll give you the another example. So let's change, this one is now concave. So then let me redraw picture. Now your lens is concave, right? And then this is your central line. And your focal point is again 12 centimeters. So it's a 1 unit, 2 unit, 3 unit. And then another 1 unit, 2 unit, 3 unit. So this is your F. This is your F. Right? And the object is again 8 centimeters. So this is your object. And then again, now I assume this is a concave lens. Your first line, parallel, same, but we don't use this focal point, right? But we will use it, this focal point. So then directly to the focal. So this is gonna be your first line. And the second line is directly to the center. So this is where your image will be formed. So the size is smaller, direction upright, and then this is again virtual image, right? Why? Because the image is formed the same side as the object for this lens. In the last example, you will see you gotta do the same thing for this case. Now I'm gonna change this lens again for concave. And then we'll do the same picture. And then straight line. And then again, this is a 12, 18 centimeter. So then now you see each unit is a 6 centimeter. Right? And then you have another 6, roughly the same. Right? So then this is your focal point. And then your object is 18, so another you need a weight. So okay, this is my object. And then first line parallel, but you can have an imaginary, right? Lens. You can, your lens is here as well. And then again, because this is a concave lens, we assume we don't use this focal point. And then first line is a parallel to here, right? To the focal point. And the second line directly to the center. So this is where your image is actually formed, right? So then all done, right? So again, images are smaller, upright, and again, virtual. Why? Because it's images form the same size as the lens. Okay, so this is the end of the, you know, third topic for your second exam. So your second exam will cover chapter 16, 17, and mirror and lens. I'll upload information about your second exam, and I will also, I think some of you, did a long homework for, homework 16. So make sure double check your messages in Canvas, okay? See if you did the right homework for chapter 16, okay? And I will upload the second exam information today. And then let me know if you have any question. Thank you.